You got into college, right? That's amazing, man. Congrats.
Yeah, thanks, but I didn't get much aid. Why is college tuition so high? I'm gonna be in debt for decades.
Yeah, word. I guess we gotta start saving now and get a side job. Like, I'm babysitting, but it's totally a drag. If only there's a way to, like, have fun while we make money for college. What if we start a band?
What the fluorine? We could always pull a Breaking Bad.
Why are you guys laughing? That's actually such a good idea. We could make, like, sky-high stacks, yo.
You want us to make meth and sell it? Not a good idea, Julian.
Not original either.
You think I'm a moron? Okay, no, not meth, alright? Use your minds.
Adderall!
Obviously.
That's it! We can use our Orgo knowledge to make money. For college. Why didn't we think of this before?
Okay, let's figure this out.
Wait a second. Why do you know the structure of Adderall?
Eric, I just need you to focus right now, okay? So first, we start with allylbenzene. Benzene group here.
Allo. That means one away from a double bond, right?
Yeah, exactly. So allylic carbons and benzylic carbons are both really good for holding radicals and carbocations. So then after this step, we're going to treat our allylbenzene with acid.
This causes a Markov-Nikov reaction. Where the hydrogen goes on the less substituted position, and the carbocation forms on the more substituted position, in this case, secondary.
Secondary, because the carbocation, which is on the alpha position, is flanked by two beta carbons.
So the plus charge means that that carbon is electrophilic, meaning that it wants electrons. And it can get those electrons from the lone pair of a nitrile group, which is nucleophilic, meaning that it wants to give away its electrons to an electrophile. And we can draw the product, which looks something like this.
The lone pair looks like a pair of cartoon hands, waiting to grab onto something. This arrow shows us what reacts. We want the element with the electron hands to grab onto an electron-deficient molecule.
Let's do a carbon count to make sure we didn't lose anything. Good, but don't forget the positive charge on the nitrogen. Remember, the formula for formal charges is V minus B minus D, valence minus bonds minus electron dots. Okay, add a plus minus and we're done, since this reaction makes racemic amphetamine.
Wait, I don't understand. What's that for?
This is a racemic mixture, meaning we produce 50-50 mix of an enantiomer. First, enantiomers are from asymmetric or chiral molecules.
We can generally tell whether molecules are chiral based on whether or not they have asymmetric carbons. Those are carbons with 4 single bonds attached, therefore 4 domains, like, for example, this 2-butanol molecule.
Enantiomers are mirror images of chiral molecules. Pretend that there's a mirror behind this 2-butanol. Now, since you can't drop this first molecule on top of this second molecule, they're considered enantiomers.
How do you differentiate the two if you don't have a picture of one of the molecules?
Well, actually, chemists use RNS notation to determine this type of phenomena. We can actually use this cool chart right here to figure out which mirror image of the molecule we're looking at. And to do this type of thing, we have to determine the priorities of the substituents attached to our asymmetric carbon. So if the lowest priority substituent, like this H right here, is going behind the molecule, and additionally the order of other substituents from highest priority to lowest priority is clockwise, like this right here, we can say that the molecule is R. Now, on the other hand, if that order of highest priority to lowest priority substituent is counterclockwise, like this here, we can say that the molecule is S.
Now just reverse the rule if the least priority group is in front, like this H. So if it's going clockwise, it's going to be S, and if it's going counterclockwise, it's going to be R. So in this case, we see that it's still 1, 2, 3 clockwise, but since the H is in the front, this molecule is going to be S.
Yeah, exactly. So now that we figured all of that out, let's just go buy some reagents to make our Adderall.
Maybe this wasn't the best idea.